So I'm sorry that I cannot be there today. Unfortunately, I have some COVID-related issues which make it impossible to leave my house at the moment. So my name is Teun Keusters. I'm a deep learning engineer at QING Group, where I actually work most of my days on the implementation and integration of deep learning algorithms, mostly within computer vision applications. And that's also why I've been asked to tell you a bit more about how we at QING approach these kind of projects. And I want to do this by showing you one of the cases that we actually worked on last year. But before I do this, let me first introduce QING Group as a company a bit more, who we are, and especially what we do and how we approach these projects. So QING is an engineering agency, but moreover a development partner for companies within the agricultural and food industry. And within this industry, we see that we have some global challenges to face in the upcoming years. So first, there's of course a growing world population, which means that we have to deal with more mouths to feed, basically. And this is combined with the fact that resources are getting more scarce, and that due to climate change, we will need to be able to be more aware of the way that we spend our energy. So these things combined mean that we will have to be able to produce more food with less resources and less energy. And we think that one way to approach this problem is by having industry accelerate their innovation. And that's also where we see our role as a party who helps producing companies within the food industry by decreasing the cost, the lead times, and the risks of their development process. And we do this by offering actually a wide variety of different technologies, both and new. We can build mechanical machines, but we also offer the newer technologies like digital twinning, where we, for example, simulate real-life processes or products or machines in order to gain some design insights, to find some risks, or to gain any knowledge about the process in another way. We do a lot of data-related projects, and of course, we work within the area of machine learning and deep learning, which is what I'm talking about today. So what needs to be said is that QING is no development. We don't develop these technologies, but we try to implement them and make them accessible to our customers as efficiently as possible. And if you want to use these technologies, be able to combine them within new ways or use them within new applications, then you need to be able to quickly test whether your assumptions are correct. So that's also what we do. We try to validate our concepts or our ideas by creating proof of principles, proof of concept in our development on them. And in that way, we quickly try to gain insight in the possible directions of solutions to a problem. And this way of working, where we try to, in quick, short cycles, try to get insight in the problem that we are solving, is actually at the core of how QING is working, the way that we approach innovation projects. Actually, so much that we gave it a name, which is the development roadmap. And this roadmap basically describes how we approach every development project. So we start with a challenge, then we sit together with a bunch of engineers and come up with different design solutions. And then we pick the most promising ones and we quickly start doing some research, doing some proof of concepts or some simulations in order to get an insight in the problem, to define some risks, to find out about some unexpected consequences of the solution. And we use the outcome of these small researches to change the direction of our development project if needed. So if we then need to do another cycle, we do another cycle. If we need to do another cycle, we do another cycle in order to as effectively and as efficiently as possible head to the eventual realization of a solution. So this way of working is how we actually approach most of our development projects, and it's also how we approach the case that I want to talk about today, which is totally centered around oyster mushrooms. So some time ago, we came into contact with Verbrugge Paddenstoelen, which is actually a mushroom farmer in Brabant, and they had recently opened a new facility to produce oyster mushrooms. And I didn't know this. I'm guessing that you don't know this either. Oyster mushrooms appear to be the most booming mushroom of all. So its popularity has increased a lot over the last years, and it's still increasing, mainly due to the fact that it's used widely with as an ingredient for imitation meat and other meat substitutes. But also consumers are better capable of finding it in the supermarket. So, due to this popularity increase, Verbrugge decided to open this new production facility, and they asked us whether we could help in identifying what parts of the process they could innovate. So we went there with a bunch of engineers, and we tried to get to know the process and the product as quickly as possible. So what we learned about oyster mushrooms is that there's basically 3 different classes of mushrooms. There's the high quality class, which is bought by restaurants and culinary facilities. And this class is actually not defined by the taste, but it's defined by the size of the head of the mushroom. So you've got the head and the stem of the mushroom, and the size, the diameter actually, of the head of the mushroom is leading in which classes. So this is the high quality class, which contains the small mushrooms of up to 30 millimeters. Sorry, did someone say something? No. Oh, okay, sorry. Then I just misunderstood. Okay, so this the medium quality class then, which has a head diameter of up to 80 millimeters, and there's the low end class, which is basically high volume and is bought by companies that use it as an ingredient in other products. So this process of sorting the mushrooms into different classes is still done manually. So there's an operator who has a sheet, and on the sheet is a bunch of circles in different diameters. And by holding the mushroom in front of the circles, the operator can determine the size of the mushroom. But this is very theoretical. In practice, it turns out that operators need to be so quick that they will just trust on their subjective judgment to decide in which category the mushroom is. And actually, a lot of value is wasted in the step, because if you divide a very big mushroom into a smaller category, then this might lead to the entire batch being rejected. If you do it the other way around, you're putting a high value product in a low value category, which is also a waste of time. So we determined that we could most easily start innovating in this part of the process, and to be able to automatically sort the mushrooms based on the size of the head. So after establishing this together with the client, we decided that we needed to be able to first, in order to measure the head of the oyster mushroom, we needed to be able to visually separate the head and the stem. And what we always do in such a case is doing this small proof of principle. So we talked about deep learning, or the speakers before me talked about deep learning and about traditional computer vision. We always first try to do a case with traditional computer vision, because it's just, if it's possible to do it in this way quickly, then you just integration is just way more easily. So we try to figure out some parameters that seem to separate the head from the mushroom, from the stem from the mushroom, each and every time. But we quickly found that there's just too much variability between certain mushrooms. So there's some mushrooms that contain a very dark head, others have a very light head. There's mushrooms with long stem, with a shorter stem, or some don't even have a stem. And also the direction of growth varies. So some grow from the bottom to the top, while others grow from the left to the right. And this makes that the shape of the mushroom is very different, which in turn makes that the mushroom falls on the conveyor belt differently each and every time. So bottom line, there's way too much variability to do this quickly with a traditional computer vision application. So in such a case, we decide to start doing a proof of concept with deep learning. And actually, in most of the cases, this is the reason for us to start working with deep learning when there's just too much variability with the subject of interest. Especially within food, this is often the case. Food products often have a very variable shape, and oftentimes we fall back to deep learning to solve these cases. So it's not the only reason to start working with deep learning. Another reason, for example, is the fact that it's easily scalable over different projects. So an example is a project where we worked on a machine or a deep learning application that was able to analyze a certain type of dough, bread basically. And after deployment, the customer wanted to be able to use the same hardware setup to analyze a different kind of dough that was produced by the same machine. So we had actually two kinds of bread that we needed to analyze. And in this case, it was just a matter of creating a new data set, labeling it, training it, and we were ready to deploy second deep learning model too. Whilst for traditional computer vision, this would probably mean that you would need an engineer to revise differences between those two products and then accordingly change the software. Another advantage of deep learning, in my opinion, is the fact that it's capable of dealing with unstable surroundings. So if it's very difficult to get a stable lighting environment, for example, if you're working in an outside application, or if there's a lot of dirt and debris that can form on the conveyor belt, then it's really efficient to start working with deep learning. And one thing that I also hear Jens say with the Hering case, especially within the food, when you're working with organic products, these products tend to change over time. So that was the case for the herring. It's also the case for a lot of different kinds of meat. And I also know of a case that one of our partners actually did, where they analyzed certain types of plant bulbs. And after deployment with high performance, after a while, it turned out that the performance had decreased. And what turned out to be the cause for this is that the species of plant had been developed, had been evolved actually. And due to this product change, the algorithm wasn't capable of reaching the same performances as it did before. So again, for traditional computer vision, this would mean, in best, it would mean tweaking some parameters. At worst, it would mean having to change your entire algorithm to fit this new, actually new product. Whilst in this case, it was just a matter of collecting a new data set of like 300 images, labeling it, and updating their model. And the company was ready to work with high performance models again. So the last reason that we sometimes use deep learning, though this is quite a tricky one, and I'm also quite certain that people who wouldn't want to do this, is to basically digitalize human expertise. We often encounter human experts who often do quality control in a subjective way. So they rely on their experience to do quality control, and they find it very difficult to put this into clear rules, into clear logics. So in such a case, it might be beneficial to do a joint classification session, and in that way, actually let the machine learning algorithm figure out the human expertise. The big disadvantage of this, however, is that people, when doing a subjective judgment, are often have a quite high error. So if you want to do this, I would advise you to first define the human error, the error of your expert, which your machine learning algorithm obviously won't be better than that. So just to give you an idea of the different projects that we work on, I have listed the 4 deep learning methods that we mostly use, which is basically classification and segmentation. object detection, and anomaly detection. And I want to give you an example for everyone, just to give you a sense of the different range of projects that we solve within this industry with this technology. So there's classification, which is basically dividing an image into a certain class. And the example that I have with this, if it works, yeah, is this cookie example where we wanted to be able to determine whether the decoration was actually put on top or on the bottom of this cookie. And we created two classes: the good class, where the decoration was put on the top, and the bad, the reverse class, where the decoration is put on the bottom. So then there's segmentation, which is basically what we're talking about today. Letting the algorithm indicate what part of the image, what pixels of the image contain the object of interest. So in this case, the head of the mushroom. Then there's object detection, which we actually rarely use separately. We almost always use it in combination with one of the other three algorithms, which you could use it, for example, to determine the density of this plant in a field. And then there's anomaly detection, which is basically training a standard shape and later with deployment, excluding everything that differs from this shape. So where we applied it is in this dough example. I don't have a real life image due to confidentiality issues. We worked on a dough product where we trained the standard shape, and everything that differed both in shape or on the surface, some debris or so, would be rejected, would be classified as not okay. So by showing you these four examples, I hope to have given you an idea of the amount of cases that we can solve with deep learning within this industry, of the capabilities of this technology, but there's also quite some challenges when starting to integrate deep learning. Let me first get started with the technological challenges. So before, I heard already some people talking about the black box. The black box argument is some criticism on deep learning that you often hear. And of course, it's very valid criticism. It's a big disadvantage of the technology. Within our industry, within our practice, we don't have to deal with this disadvantage too much. What we generally see is that there's so many cases where the performance increase is so huge, or you can even do cases that we couldn't do before with traditional computer vision, that greatly justifies working with this black box. We do, however, try to keep as much information outside of the black box as possible. So in the case of the oyster mushrooms, we want the learning part to indicate what pixels of the image contain the object that we are interested in, and we don't want to do any mapping from millimeters to pixels, or we don't want to determine in what direction to measure the head of the mushroom, because that's all things that we can do with just traditional ways, and then we don't do it with deep learning. We only want to use deep learning when it's the most effective way to do a certain task. Also, we often work with existing machines, and it can be quite challenging to incorporate deep learning within this existing machine. There's often a PLC or an industrial PC with not too much computing power, and the architecture basically isn't fitted for deep learning applications. So how we try to approach this is keeping the machine and the deep learning part as separate as possible. So we have a machine and we place a computer next to it that does all the computing, that does all the learning. And the only interfacing that we let happen is basically trigger when the picture is taken and a conclusion. So a classification result or a coordinate, or maybe an okay or not okay, a reject, don't reject. But we try to keep this interface as separately as possible. This is both convenient for implementation, but also for maintenance, because oftentimes the people that are trained to maintain the machine originally aren't capable of maintaining the deep learning application. And in that way, we can keep this separate and, if necessary, do the deep learning maintenance ourselves. Also, we try to experiment a lot with custom neural network architectures when we first started with this technology. And we had some performance increases, of course, but we also found that the amount of time that we need to do these optimizations often doesn't justify I have to say the other way around, actually. The increase in performance doesn't justify the amount of time that we need to do this optimization. So what we actually concluded is that for us, it's most convenient to just work with standard architectures, like a ResNet, for example, that are well proven, well researched, and it's only after deployment that we possibly try to find some different architectures to get this small increase of performance. But my personal preference is to first start looking at other things like the lighting. We had some interesting discussions before about how different types of light can improve your image. So I'd rather experiment with that than having to experiment with my network architecture. So there's some technological challenges. It can be quite a hassle to start working with deep learning, but to be fair, the technological part, the technological innovation isn't the biggest issue when starting with deep learning, in my opinion. And our experience is actually more about social innovation. Being able to get all your stakeholders on board and getting them all enthusiastic about starting with this technology. Because we often feel that there's quite some people that feel restrictions, that have some fears or doubts, and it can be quite a challenge to overcome these feelings. So probably this is something that you recognize. It actually counts for a lot of new technologies. And let me first make this quite clear. We are still very much learning within this area. It's really difficult to overcome these kinds of resistance. And some days we are very successful, other days we are less successful, but we do have developed some good practices. And at the start of this presentation, I talked about how we always try to do these small researches, these proof of concepts. We are actually in this presentation doing one right now for the oyster mushroom case. And these proof of concepts can really help people in develop a better understanding, a better intuition for how deep learning is working. Because from my personal experience, what I've encountered is that this resistance and these fears are often caused by the fact that people lack the intuition for deep learning. So for how the neural network is actually functioning, why is it that so many computations from such complex behavior, but moreover about the process that involves starting with deep learning. So what risks are related to this implementation? How much time will this cost me? How much money will this cost me? Won't the machine take over my decision process? So will I, as a manager or as an owner, be still in control over the quality of my own product? And also, how does this deep learning work? And then I'm talking about, for example, collecting a data set, labeling your data, using this labeled data to train a network. That's all, the intuition for this process is all lacking. And this proof of concepts can really help in developing this understanding. First of all, because we show the feasibility, and it gives us a chance to define the risks better, get a better insight in the costs and in the steps that need to be taken to go to implementation, but just as much to show the process, to help people starting to understand this technology. And in my experience, this is really effective, together with talking a lot and explaining a lot. And so, like I said, sometimes it can be very successful, other times it's more difficult. Generally, I feel that doing this proof of concepts helps people getting on board with this technology. And then secondly, I also encounter often that it can be quite overwhelming to start with a new technology in your business, because you don't have an idea of what steps to take. You don't know what expertise you need. You don't have any knowledge within your company. So it can be quite overwhelming to have to deal with all of this stuff at the same time. And that's where we as King try to facilitate this process and make it as fluent as possible. So first, we will start doing this as low key as possible. Start with the most accessible business case. And it's only after deployment that we will start to hand over responsibilities. So directly after deployment, we will train operators. And then after some time, we will hand over the maintenance, but only step by step in the pace that the company that is using the technology can handle. So one extra side step is this image. It was actually published in 2013, and it's an image that I use often to help people understand the actual technology, the actual convolutional neural networks, and why it is that so many small computations form such a complex behavior. So what we see in this image is basically a car classifier. It returns whether the image that you see at the left of is a car or is no car. And what we see is that if we go into the lower levels of the neural network, so the earliest layers, we distinguish only very basic things. For example, some diagonal edges or some horizontal edges, some small contrast differences, but basically the basic stuff, the things that you could also easily find with traditional computer vision. If we go somewhat deeper into the network, we start seeing these very basic features being combined to somewhat more complex things. For example, 3 or 4 curves in a certain pattern will be combined. 3 or 4 edges in a pattern will be combined to a curve, and some contrast differences will be combined to a certain color pattern. And if we go even deeper into the neural network, we see that these very basic concepts are being combined to more complex shapes. So a few curves in a certain pattern can be seen as a wheel or a grill, or I see a window if I'm correct. And would we go even deeper into the network, then we would be able to see all these components, all these features being combined to eventually judge whether we are looking at a car or not. So I find this picture really helpful when I just take it and talk about it with someone who's new to deep learning. Just talk for 10 or 15 minutes, and it really helps them in developing this understanding and intuition for the technology. If it doesn't work for you, don't matter. It doesn't work for everyone, but if it works for you, it might be helpful in the future. So after the side step, let's just go back to the case that we were actually talking about, where we concluded that traditional computer vision wouldn't be the way to go in this case. And as an alternative, we started collecting a small data set of mushrooms. It were 235 examples in this case. And we quickly started labeling these images. So what you might see is that we don't use custom software for this. We use standard software for it. We could write the software ourselves, but we find that it's just way more convenient to use standard software, which helps us implementing this technology as quickly and as efficiently as possible, and as reliably. So we use standard software for labeling, but we also try to use standard software for training neural networks and deployment as often as possible. So there's quite some very useful packages online at the moment, for example, RoboVision or Peltarian. And we try to use these software packages first, train the networks, and then also for deployment, because this standard software also can help our customers in being able to maintain and deploy and retrain the algorithms much better than with custom software that we would have written. So oftentimes we will do this labeling together with a product expert. First of all, to make sure that we understand every detail about the product, but also to give them a sense of how this is working and to help them develop this understanding of how this classification session influences the training and then influences the behavior of the algorithm in the actual deployment. So I think that this is some really important stuff to understand for the people that have to work with this technology. So after labeling, we continue training. And during training, we only care about showing the potential and showing certain risks. So we want to explore whether this technology is feasible in this application, but we also want to show the power and the capabilities of this technology to our customers. So actually, to be honest, what I personally care a lot about is getting our customers enthusiastic about starting to work with deep learning. And in this case, when we see the results, I think they're already really impressive for an algorithm that was only trained with a small data set of 235 images. We were already perfectly capable of measuring the size of this head, and in that way, we perfectly showed the feasibility of this technology within this use case. So we also provided some follow-ups because, of course, we needed to be able to measure the head of the mushroom, but we also needed to be able to automatically sort it. So we provided some follow-ups in where we defined how to automatically sort these oyster mushrooms. And then it's up to the customer to decide whether they are ready to start working with this technology. So let me summarize. We defined that we wanted to be able to measure the head of the mushroom. Then we decided that to do so, we needed to be able to visually separate the head from the stem of the mushroom. We did two quick proof concepts. One, to see whether we could easily do this with traditional computer vision, which was not the case. And then we tried to do it with deep learning. And there we showed technological feasibility, and we provided some follow-ups. And like I said, now it's time to for the customer to decide whether they are ready to start working with such a technology in their own practice. And that's, I think, the bottom line of what I want to share with you today, is that to start working, start implementing deep learning on a large scale within industry, we jointly need to be able to better convince people of the power and the potential of deep learning for everyday applications. So if I would have been there, I would have loved to talk with you about your view on this. I would have loved to learn from each other. So feel free to contact me on one of those things. And I also would encourage you to jointly discuss this and to see whether you have some interesting insights about this. So for now, I would like to thank you for your attention.
Thank you. I don't know if there are any questions. I don't know if there are questions, but we can try to pass around the mic and see if you can answer some.
Sure.
What is your experience with the accuracy of deep learning? So are you able to do like 95% accuracy or 99 or?
Accuracy is very difficult to. It's really difficult to give a general answer for this because, of course, with segmentation like this case, it's very difficult to define accuracy at all. So let me just refer to the classification case that we worked on, and also there it's very dependent on the application. So we've got some examples where we reach like 99.9% accuracy with just the standard network architecture. But we also have some cases where we only reached 85, and that was already sufficient for the client. So what I think is that there's a lot of cases that would already be a great success with only an accuracy of, let's say, 90%. And I think it's just a challenge for the entire industry to find these cases and to solve them with deep learning. And then we can focus on more difficult ones.
Thank you.
Hi, I have a question from very no knowledge about AI, but curiosity for what could be applicable for our internal project. I've seen that you mentioned classification, and my curiosity is how AI is dealing with having a picture that actually doesn't match to any of the class of the groups that it is already learned about.
Yeah. In such a case, it would divide it into a class anyhow. So if you would have a lot of these cases, I would advise to either use an anomaly detection algorithm in front of your classification algorithm, or create a class which is like an orders class, where you put all your order examples, and in that way you could then if there would be uncertainty over in which class to divide the image, then it would probably put it in the other category.
In that case, then we can analyze to understand what it is. Okay, thank you.
No problem.
Yeah, you were saying that you were able to measure the size of the mushrooms by the pictures, but isn't the picture you're using a 2D picture? Isn't that this perspective?
Yeah, you mean like the camera is looking like this?
Yeah, but also the orientation of the mushroom, because if the orientation of the mushroom is on its side, then the area you measure for the mushroom size will be different, right?
Yeah, the convenient thing about this is something that we actually showed in another proof of principle that I didn't talk about, is that the mushroom always actually falls on its top or on the biggest side. So in that way, we always have a view on the biggest measurement, and that's also the one that we are interested in. So for this case, it's conveniently that we didn't have to tackle this. For another case, it would mean either having to deal with it by using two views, or using perhaps 3D analysis where you use a point cloud instead of an image.
That makes sense. One short order question. You said like organic products like meats and mushrooms change over time. Does that mean that your clients come back to you after a while because their algorithm doesn't work anymore because their products are different and you have to retrain them? And if so, is that part of your business model?
No, what we try to do is give our clients as much control as possible. So that's also one of the reasons that we use standard software, because the standard software makes it really easy for them to do this retraining themselves. So it could be that a client call us with this problem, and that we would say, okay, you need to retrain it, and we could do this for you. But we always aim that they can do this independently.
Okay, thank you.
No problem.